Yeah. Good evening, everyone. So, Shana Camps, let's start off. Sure. It's been a long time. Hope everyone remembers me. So, let's start off. So, last thing we did was the differentiation of a vector. Others do keep your cams on. So, we'll be starting off with the applications part. So, till last class, right, what we did was the basic math part. Basically, how to differentiate and all that stuff. I showed you the 3 levels of differentiation, the basic one and the identities, and then we had the chain rule. The chain rule was the most important one. Okay. Others, Devika, Devansh, cams on. Now, the applications, right? The first one is based on kinematics. Now, if you choose R bar is your position vector. So we give velocity vector V bar is given by dr by dt. The rate of change of position is called velocity. Acceleration vector A bar is given by change in velocity, that is dv by dt. This can be also written as acceleration can be written as dv by dt and dr by dr. Dr by dr is anyway 1, and this quantity becomes v again. So remember, acceleration has 2 formulas. So acceleration can be written as v bar dv by dr. So basically use this. If v is given in terms of r. In terms of position. Use this if v is given in terms of time. We'll do some practice, you'll get the hang of this. I think you should copy down this thing. Put it down. Note down this stuff. These things actually come from kinematics, but I hope you have a basic idea. Velocity is nothing but change in position by change in time. Acceleration is change in velocity by change in time. That is the whole meaning of the symbol d. D means change. So, but when we say d, it means a very small change. Just put on, this one, and this one. That's it. And don't worry about the remaining part of the notes. You'll be getting the PDF anyways. Just put down this stuff. One dimensional, we'll write acceleration as dv by dt or v dv by dx. More about this, right? In more detail, we'll be doing it in kinematics. Copied? Okay, so let's go ahead. So let's see some problems. X is equal to t cube by 3 minus 3t square by 2 plus 2t plus 1. So basically, x is the position here, x is the x coordinate. Find velocity and acceleration at t is equal to 1 second. Let's get this. Someone gave you position. We are asking for velocity and acceleration. Just to give you an idea, A is dv by dt, but v itself is dx by dt. So in one dimension, right, r becomes x. So basically, I'm asking you to differentiate 2 times for acceleration. Give it a try. Take a minute. It's basic x power n ka differentiation. Soham, to adjust your cam, I can't see your face. Make sure your faces are completely visible on the screen. Sanya, Devika, do adjust your cams a bit. Full face should be visible so that we are sure you're not eating any cake secretly. Yeah. Velocity is 0. Okay, fine. Get the acceleration also. Should I help you with the first one? You guys forgot, I guess, differentiation. Make sure to revise the notes once today. So what is V? dx by dt. So the first differential is 1 by 3 dt cube by dt minus 3 by 2 dt square by dt plus 2 dt by dt plus 1 ka differential. 1 is a constant. So t cube ka differential is 3t square. 3 will cancel, you'll get t square. T square ka differential is 2t. 2t will cancel. 3t. This is 2 and that is 0. Right? Easy. So this is your velocity. And what is the acceleration? dv by dt. So differentiate this again. So dt by dt t square minus 3 dt by dt plus 2 ka differential. So this guy would be 2t minus 3. There. So I got velocity is t square minus 3t plus 2. This is a velocity as function of time t. At t is equal to 1. So when you say this, simply put t is equal to 1 here. So 1 square minus 3 into 1 plus 2. That is 0. Acceleration is 2t minus 3. At t is equal to 1, acceleration is minus 1 meter per second square. Easy? Have a look at this. Any doubts on this? We simply used x power n ka differentiation. Brijesh, Arush, Devansh, Mridul, clear with this? Easy stuff. Next one. Aishwarya, clear na? Right? Yeah. Similar one. X is t cube by 3 minus 5t square by 2 plus 6t plus t. Find velocity when acceleration is 0. Same question, but this is a different way of asking. Let's get this. You got an answer, do type in the chat box here to the co-host. Okay, we have one answer, 29/4. Anyone got the same? Okay. .25. First, let's find the velocity. So this would be t square minus 5t plus 6. Acceleration is, again, differentiate the velocity. So basically differentiate this guy again, which is 2t minus 5. Now it is said when a is 0, that means 2t minus 5 is 0. So time is 5/2 seconds. So indirectly the question became find the velocity at t is equal to 5/2. So velocity t is equal to 5/2. Just substitute there. 5/2 whole square minus 5 into 5/2 plus 6. That's 25/4 minus 25/2 plus 6. This is minus 25/4 plus 6 minus 1/4. Yeah, it's minus 1/4, right? Check your calculations. People who got 29/4, you must have goofed up something. So basically, you have to just differentiate it twice. So first time you differentiate, you get velocity. You get this guy. You differentiate this again, you get acceleration. So this is basically here it is standard. But the question is saying find velocity when a is 0. So put a is equal to 0. From there, get the time. Now that time, take it and put it in velocity. So if you see this and the previous question are same, but the way the wording is a little different. Previous question times are given. In this question, it is expected you will find the time and then you'll substitute back. Clear, everyone? Any doubts on this? Devansh, clear with this? Sania, clear? Tanish, Sashwat? Next one. Archita, clear with this?
Yes.
X is equal to k into 1 minus e power minus bt. Here k and b are constants. Find initial velocity and final velocity and initial acceleration. Sometimes they won't use the words, time 2 seconds, 1 second. They will use the word initial. So this initial implies time 0. Initial, meaning the point when the motion starts or when the equation was framed. So whenever they use the word initial velocity, indirectly they're saying time is 0. So initial implies time is 0. Keep that in mind. So sometimes they will say initially find the initial velocity. The initial acceleration is the initial velocity is 2. So indirectly he's saying at t is equal to 0, the speed is 2 or whatever. So instead of saying the time t is 0, they will simply say initial. Let's get this. So x is equal to k into the whole thing in the bracket 1 minus e power minus bt. E is that exponential. K and b are constants. Find the initial velocity, find the final velocity. The final velocity is an interesting thing, and initial acceleration. Let's get the initial. I'll tell you what is final. This final thing actually doesn't make sense for every equation, but this exponential functions, right? It means something. This is a pretty common equation actually. We'll encounter this a lot. Try. You got 2 minutes. Just first differentiate it 2 times. We will see initial, final. We will see about that later. Initial velocity. Right home. Yeah, actually, final velocity. No, let's not do that. We'll see that later on. Yeah, but actually, it's not valid here also. Generally, when we say final, right, we take time infinity. So what we do? Let's differentiate. So velocity is dx by dt. K is a constant, so d1 by dt minus d by dt of e power minus bt. So k, 1 ka differential is 0. E power minus b ka differential is e power something. Remember, this is a chain rule. So this guy on the top is that some function. So e power some function is that e power the same function, and then differentiate whatever is inside. If you remember, that's how we did the chain rule. That minus minus will go off. You end up with kb into e power minus bt. Hope that is clear. Anyone is confused with that, please ask me. So at t is equal to 0, when you say initial velocity is equal to k into b into e power 0. E power 0 is 1. So acceleration is dv by dt. K and b are constants, so it just comes out. So this is dt e power minus bt. This guy would be minus kb square e power minus bt. Again, at t is 0, acceleration will be minus kb square. Check. So when they ask you differentiation, if you remember this question which I taught you, no one is going to ask you like this. For example, these examples said no one is going to ask questions like this. They'll always ask you in terms of, velocity or acceleration like this, they'll be asking you. Do check it out. E power, it's some function. So you have to differentiate that bt again. Any doubts on this? Right, Sanya, you got the answers. Anyone else? Arish, you also got it. Om, you got it. Yeah. Clear? Next one. Any doubts? Archana, clear with this? Arush, Brijesh, Aishwarya, clear? Mridul, Shashwat, Soham, Tanish. Perfect. Next one. V is root over t square plus t. V is root over x square plus x. Find acceleration in both the cases. Two different questions. V is velocity. So velocity is given by root over t square plus t. T is time. X is position. So I gave you velocity and I'm asking for acceleration. Let's get this. Q plus t square plus 1. Nay God, how did you get that? It's a root. Okay. Should I show you the first one? What is acceleration? dv by dt. So how do we differentiate this? dy dt t square plus t whole power half. Didn't we learn how to do this thing in the last class? This one, isn't it? Meaning x t ka place mein x is there, but if you remember, it was this differentiation chain rule. So t square plus t whole power half. So this is like some function to the power of half. So this is looking like x power half, but it is not x power half. It is some function to the power of half. Then how do you differentiate half into that some function t square plus t n minus 1, n is half. Then differentiate whatever is the function inside. This is the chain rule, isn't it? It is some function to the power of half. It looks like x power n, right? So you just have to differentiate the t square plus. I just said find acceleration, right? I didn't say initial acceleration. So differentiate this. So this is 1 by 2 root over t square plus 2, and this differentiation will be 2t plus 1. So 2t plus 1 by 2 into root over t square plus t. That's how you leave it there. That is the answer. Have a look at this. So chain rule, they're going to ask you like this. No one will come and ask you find this function. End of the day, you have to do that only, but they'll give you some velocity and they'll ask you in terms of acceleration. Can you do for the B part now? B is similar one, but yeah, there's a small difference. what is the difference between this and the second part? The second part, v is given in terms of x. So be careful. This is what I wrote here. If a is given in terms of v is given in terms of time, use dv by dt. But if v is given in terms of x, use dv by dx. So you can't use dv by, you can't say a is dv by dt. Okay, this is fine, not a problem. But this v is not in terms of time. Since here v is in terms of x, acceleration, right? V dv by dx. I hope you're getting the difference. Because the function is depending on x, you differentiate v dv by dx. If v is in terms of time, use dv by dt. So if I do dv by dx, same thing, I get the same formula actually, 2x plus 1 by 2 into root over x square plus x. So the acceleration v dv by dx, root over x square plus x. Because see, dv by dx and dv by dt, they look the same. So x ka place mein t will come, or t ka place mein x will come. This root x square plus x will cancel. You end up with 2x plus 1 by 2. Please check. Right, Sanya. Aishwarya, Arush, Devansh. Yeah, all of you got it right. Do have a look at this. Clear? Turn in the page. Aditya, clear? Next one. V is equal to t square I cap 4 by t j cap plus 3k cap. Find a time when acceleration is perpendicular to velocity vector. Now it's a vector form. Last class we did this, how to differentiate a vector. Let's get this. So velocity v bar is given by t square I cap 4 by t j cap plus 3k cap. Try, you got a minute more. So now it is differentiate the vector, you'll get acceleration. And even if two vectors are perpendicular, what is zero? The dot product. So whenever you use the word two vectors are perpendicular, indirectly it's telling you to use dot product. That is a clue. That is the biggest hint. The moment, it doesn't matter which chapter, two vectors are perpendicular, discussion closed. 99% you first do the dot product is zero. Right, Devansh. Arush, we have two answers. Others, Brijesh, you got something else. We have two root 2s and 1. Even I feel it is root 2 only. Anyone else got root 2? We have 3 root 2s. So how do you differentiate a vector? You just differentiate the quotient of I cap, j cap, k cap separately. So acceleration vector. Now, what is the difference between this and the previous problem? In the previous problem, if you see, there is no I cap, there is no j cap, nothing. Meaning these are one-dimensional. Meaning they're just going in one straight line, mostly maybe along x-axis or y-axis, z-axis. So if no one gives you anything like this, means this is all one-dimensional motions. So we can assume the motion is going only in x-axis. But if I give you like this is a motion in three-dimensional. The particle is going in some weird path, like in like something like this. You do have weird paths like this. So acceleration is dv by dt. So t square ka differential is 2t I cap. For 1 by t ka differential is minus 1 by t square. And that is 0. So acceleration vector is 2t I cap. 4 by t square j cap. Since a bar is perpendicular to v bar, a bar dot v bar should be 0. You know how to do the dot product. 2t into t square, 2t cube minus 4416 by t cube is equal to, there is no k cap, is 0. So this is t power 6 is equal to 8. So t is equal to, this is 2 cube whole to the power of 1 by 6. So 2 to the power of half or root 2. Yeah, have a look at this. This was the last problem which we had done in the last class actually. Have a look at this. Any doubts on this? Next one. Brijesh, got your mistake?
Yes, sir.
Mridul, clear with this? Devika? Pushkal? Tanish? Any doubts on this? Archana, got the answer. Great. Next one. Anyone didn't get any particular step, please don't hesitate, ask. And focus only on solving the problems. Don't worry about the notes. You'll get the PDF. So R bar is cos 2t I cap plus sine 2t j cap. T is time. Find angle between A bar, that is the acceleration vector, and R bar. R bar is a position vector. Let's get this. So there we are using differentiation with vectors. Try. You got 2 minutes. So first you need to find acceleration vector, right? So differentiate once, you'll get velocity. Differentiate two times, you'll get accelerations. So you know a bar, you know r bar. If I give two vectors, how to find angle between two vectors? Remember this thing. Whenever someone gives you two vectors and they ask you for angle, they're asking you to use dot product. So a bar dot r bar is mod a bar mod r bar cos theta, isn't it? Where theta is the angle between a bar and r bar. So first find a bar and then use the dot product and finish it off. Try. I'll give you a minute. So there, if you see how we are using extensively, like the dot product, the differentiation, this is how it is going to be. And this is like I said, this is the advantage with the physics and disadvantage with physics. Next chapter, I'm going to use differentiation, vectors, and everything. When I teach you the 10th chapter, I'm going to use everything from 1 to 9. So if you see acceleration and everything, this is actually kinematics. So we are actually using 3 chapters right now. Let's see. Right, Arush. Sania, that's not the answer. First thing, let's take velocity v bar, which is dr by dt. So this is cos of something. Remember, this is cos of some function inside. So that would be sine 2t minus sine 2t, and you have to differentiate 2t again. Minus 2 sine 2t, I'm directly writing it. And this guy would be 2 cos 2t. To check this thing. If someone is confused the differentiation, please, I'll show you in more detail. But this is something we have done last time. And acceleration is dv by dt. So sine ka differential, again, you'll get 2, one more 2 out will come out. So every time you differentiate 1, 2 will keep coming out. Minus 4 cos 2t minus 4 sine 2t. So for angle between two vectors, a bar dot r bar is mod a bar mod r bar cos theta. So a bar dot this thing is minus 4 cos square 2t minus 4 sine square 2t is equal to mod a bar is the root over 4 cos square 2t plus 4 9 16. And that would be cos square 2t plus sine square 2t. Remember the magnitude, right? Quotient of x square plus quotient of y square into cos theta. So this side is minus 4, sine square plus cos square is 1, and that is root 16. So that is again 4, and that is cos theta. Cos theta is equal to minus 1, and theta is equal to pi. 180 degrees. Basically, a bar and r bar are opposite in nature. So it's like if this was your r bar, this was your a bar. You can clearly see the axial. They're anti-parallel vectors. So you can finish off here only axial. It is minus 4 of r bar. Isn't it? So if you just take out 4 common, you'll get an r bar here. You can clearly see here A is equal to minus 4 R bar. Without doing dot product, you could have finished it there. But okay, every time it won't be pi, you might not be so lucky. So check it out. This is how we do. Anyone not convinced with any particular thing here, please ask me. Differentiation, how did you get this 2 outside? Why there is a 4 here? Any confusion, please ask. Because every time you differentiate this thing, cos of the 2t, so that will be sine of minus sine of 2t, then differentiate 2t again, so the 1 2 comes out. So every time you differentiate this function, the 2 keeps popping out. If you differentiate 2 times, 2 will come out 2 times, so it becomes a 4. Any confusion here? Archana, got this? Clear, na? Pushkal, Tanish, Aishwarya, Brijesh, clear? Arush, clear? Going ahead, turn the page. Anyone not convinced with anything here, please ask. Don't hesitate. Don't feel shy. In case you're feeling shy, at least leave a message here. I'll explain you. But ask. Next one. Now the same question, like I said again, they won't ask you like this. So simple. We'll frame it in a better way. Like I'm saying, the max, the differentiation part is actually easy in physics. The headache is converting a problem into equation format is the biggest headache. So we have a circle here. X-axis, y-axis, and origin. So we have a particle here going with speed u. This is the c net, t is 0. R is the radius. A particle goes in a circle of radius r with constant speed u. Find r bar, velocity vector, acceleration vector at time t. What is r bar? R bar is a position vector. Let's say after time t, you're somewhere here. This would be your r bar. And we have done this. Do you remember this? We have done this in vectors. Here I asked to change in velocity vectors. This guy. Isn't this the question? 21. And walks on a circumference with speed u. Find r bar, position vector is function of time t. So we have done this r bar. So we are doing the same thing, but this time I'm asking you r bar, v bar, and a bar. Let's get this. You guys have to keep revising the notes, the entire notes at least once in every 15 days, right? As the number of chapters keep piling up, then you have to do at least once in a month. Because if you don't revise your notes, you will keep seeing the same thing multiple times and you won't understand what is happening. So a particular concept, right, will keep popping up at multiple places. Right. First find r bar as function of time t. Once you got that, v bar and a bar will come automatically. Should I show you the R bar? The biggest headache is finding theta actually. That is the confusion actually. This is theta. So once I know it is theta, you can just drop a perpendicular here. This is R. So this is R cos theta. And this is R sine theta. So indirectly the coordinates of this point are R cos theta and R sine theta. So R bar is R cos theta. That is the x coordinate I cap. R sine theta, y coordinate j cap. I hope everyone remembers this. And what is theta? Theta is nothing but arc length by radius. This is the first thing that I taught you in basic maths. Arc length is nothing but speed into time, u into t by r, isn't it? In time t, this will travel ut and it is r. So for more detailed explanation, you can refer page 54. That's your theta there. So there. So we got r bar is r cos ut by r I cap plus r sin ut by r j cap. Now you want velocity. So differentiate it. So every time you differentiate, that u by r keeps coming out. So be careful with that. R cos ka differential is minus sine ut by r. I'll just show you this once properly. So d by dt of ut by r. I hope you're getting this chain rule now. So it is cos of something. So you'll get minus sine of something and then differentiate that something inside, which is u by r comes out and dt by dt is 1. Devansh, sit straight. You're not well?
Sir, putting my ear close to the mic, sir. Yes, that's
Yeah, oh yeah, your mic is not working.
sir, a bit slower, sir, actually, lagging a lot.
Okay. Then differentiate this guy again. So this will be r. Sine ka differential is cos ut by r. Meaning, see, this differential, like I said, the max part is actually easy. So I'll be expecting you guys can do this without writing this many steps. For you to understand, I'm showing it. So that u by r comes out, r will cancel. So you'll get minus u. See, if there are 10 steps and if you can write the answer in 2 steps, you should do that. You should skip as many steps as possible. Writing more steps is not good. School may it is reverse. I know school may they ask you to write each and every step. If you do that, you'll slow down. You won't have enough time to complete the paper. If you can do the steps in your head and write the answer directly, meaning if it is in the exam, I would do that only. I won't write all this nonsense. I will directly write the answer. So learn to skip steps. But since I'm teaching you, I am trying to put it in detail so that when you're learning, it's fine. But in the exam, try to skip as many steps as possible. In the exam, what matters is only speed. What about the acceleration? Differentiate this again. So this guy would be minus u square by r. I'm directly writing it. You need to verify this. Meaning the idea is the same. Every time you differentiate, that u by r is going to come out. Please check your answers for a and b bar. Any doubts on this? Please ask. Anyone confused with the A bar part or V bar part? Anything you're not clear, please ask. Achita, clear with this?
Yes, sir, I'm still doing.
Yeah, do. Everyone should try and verify your answers. And just now you have proved something actually. So what did we prove exactly? Can I turn the page? Pushkar, Archana, clear with this? Aishwarya,
Yes, sir.
go ahead. Archita, go ahead. So what did you prove here? If you look at that acceleration, if you take out just u square by r common, you end up with cos ut by r I cap plus sine ut by r j cap. That is nothing but minus u square by r cap, isn't it? R cap is a unit position vector. Meaning if you take a vector and divide by its own magnitude, if you take this vector and divide by its own magnitude, you're going to get that only. So that means when the particle is going in a circle, this is what we are seeing. This is your R bar. This is your V bar. This is your acceleration. If you see, acceleration is A is equal to u square by r, that's the magnitude, into minus r cap, that's the direction. This is also called as centripetal acceleration. Did you learn this in school? When a particle goes in a circle, it has an acceleration u square by r. Did you learn something like this? No, it is not taught. Okay. So whenever a particle goes in a circle, it has an acceleration. You learned this thing, no? Centripetal force, centrifugal force. That was not taught in school. I thought that is there in school. It's not there. No, fictitious force, never heard about it. Okay, that's fine. So basically, this is what is happening. See, whenever the particle is going in a circle, the position vector is away from center. The velocity vector is tangential. The acceleration is towards the center. Centripetal acceleration is towards the center. Have a look at this. So we have proved this thing. Centripetal acceleration. Now, most people, right, they think the speed is not changing. You're forgetting something. Speed is not changing, but velocity is changing. And velocity is changing because direction is changing. Clear? Now, let me teach you something nice. What happens if you differentiate a unit vector? Actually, any vector with constant magnitude, but let's take a unit vector. So that means if you take a unit vector, for example, a bar is equal to 1 magnitude. So it is given mod a bar is equal to 1. That means I can write this thing as mod a square is equal to 1. That means I can write this thing as a bar dot a bar is equal to 1. Now differentiate the time on both the sides. Now when you differentiate on the left hand side, it is a chain rule. So a bar dot dA by dt f of x into g of x. So you can actually differentiate a dot product also. When you differentiate the left one, the right one will be as it is. This is the product rule. And the right side is constant. I hope you remember the product rule. So that means from here we got 2 times a bar dot dA by dt bar is equal to 0. And if the dot product is 0, what does this mean? The vectors are perpendicular. That means the vector a bar and dA bar by dt bar are perpendicular. So whenever you differentiate the vector, it becomes perpendicular. And we have seen this in the previous problem just now. R bar is position vector. What is velocity? dr by dt. And what is the angle between velocity and position vector? 90 degrees. So every time you differentiate a vector, the vector rotates by 90 degrees. So if you differentiate a unit vector, it rotates by 90 degrees. Now, what is the meaning of this exactly? So this is a very good result. You can remember this. Perpendicular if mod a bar is constant. It is not only for a is equal to 1. You can actually prove this for anything. So let me take it as a 1, doesn't matter. So you can put this thing there. Quite an useful statement. If you differentiate a vector with constant magnitude, the vector and its first differentiation will be perpendicular. Now, why is this happening? Let's see the geometrical interpretation. Think about this. When you say the vector has a constant magnitude, so whenever a vector changes its, let's say this is a bar, whenever you see the vector is changing, it can change in 2 different ways. One, it can change by changing the length of the vector, delta A parallel. So this is responsible for changing the magnitude. Means you can change a vector by changing its magnitude or by changing its direction. Or delta A perpendicular. This is responsible for changing direction. Isn't this what you wrote in vectors? Do you guys remember? A vector changes only whenever you change the magnitude or you change the direction. So you can change a vector responsible for changing direction or responsible, for changing magnitude. If both will change, even then the vector will change. So that is a possibility. Now here we say the vector changes by changing magnitude or direction or both. But here we gave magnitude is constant. So that was given magnitude is constant. That means you can't change the magnitude. So the only thing you can change is direction. Therefore, only direction changes. That means you can have only the perpendicular component. Therefore, only delta A perpendicular exists. Is that making sense? So that is the geometrical interpretation. Let me put it in a more usable form in the next page. So this is a concept, but let me show you how can we use this in a better way. So this is completely just mathematically approved. This differentiate and you get it, but you don't know like why the hell it is happening. So if you see from geometry, you can clearly see that vector will change by changing magnitude or direction, and you said magnitude is constant. So you can't do anything about it. So only this delta A bar exists, and this is perpendicular. Clear? Any doubts on this page? Please go through this page once. Anyone not convinced with anything particular and anything that's not clear, please ask. Clear? Great. Now, let's put it in a more usable form. So if you have a particle going in a circle, reason, what did you say? You said the magnitude is constant. Tell me one thing, if magnitude is constant and if something is going, what path will it take? Meaning, if I tie you to a pole and length is constant, the only way you can move is a circle, isn't it? So if you have a vector with constant magnitude and when you try to rotate the vector, the only way you can rotate is in a circle. There is another option there. So if this is your vector r bar, and when you rotate here, this is your dA bar, the change in vector. This is another way of saying the same thing. Since magnitude is constant, the vector should rotate in a circle. So this is your dA perpendicular basically. So if A bar, mod A bar is equal to 1 or constant. So when a vector with constant magnitude, this is the final usable form. When a vector of constant magnitude is differentiated, it rotates by 90 degrees clockwise. Basically, we're using right hand thumb rule. So clockwise is anti-clockwise is positive. Rotates by 90 degrees anti-clockwise. Meaning, if this is your A bar, if you differentiate it, this will be dA bar by dt. If you differentiate this again, then you get d square A by dt square, double differential. If you differentiate again, we get d cube A by dt cube, triple differentiation. So every time you keep differentiating, the vector rotates by 90 degrees. Differentiate again, 90 degrees. Differentiate again, 90 degrees. If you differentiate again, you'll again go back here. That would be A power 4. The vector just keeps rotating. And we have seen this in this question. Look at this question. The first time you differentiated, acceleration is dv by dt, velocity, it is 90 degrees. If you differentiate again, this is nothing but a dv by dt, which is nothing but d square r by dt square, double differentiation. Again, it rotated by 90 degrees. Is that making sense? That was the reason the angle became 180 degrees here, which we proved here, 180 degrees. Where did we prove that? That we proved in this question, yeah. So whenever you differentiate a vector with constant magnitude, it keeps rotating 90 degrees anti-clockwise. Why anti-clockwise? Right-hand thumb rule. We take the anti-clockwise as positive. This is the usable form. Quite a useful one. Just be careful here. Magnitude keeps changing though. Every time we differentiate, that number keeps coming out. So vectors can become bigger. We are only talking about the direction. then all will have same magnitude. Please have a look at this page. It's a good one. Vectors, differentiation, and dot dot. But are you guys able to visualize it right geometrically? Think about it. If you are tied to a rod, right, and you're here, the only way you can walk is in a circle. That means you're always walking perpendicular to the rod, isn't it? There is no other way you can walk. You can't stretch the rod. You can't compress the rod. The only way you're moving is in a circle. That means your vector is always changing perpendicular to itself. That is the whole interpretation of it. And whenever differentiate, literally rotating by 90 degrees. Is this concept clear, everyone? So in advance, they will teach you something like this, and then they'll ask you a question. All clear with this? Let's see how they'll frame a question on this. Let's say mod r bar is equal to 1. Find magnitude of dr by dt, d square r by dt, d cube r by dt cube, so on, d 13 times r bar by d 13th. Ka magnitude. Getting what I did? I took a vector, I differentiated it. I differentiated second time, third time, 4, 5, 6, 7, 13 times, and then I added all of them. And when I added all of them, uska magnitude is how much? So basically, every time you differentiate, you get a new vector. So I'm adding 13 vectors, and I want the magnitude of the 13 vectors. Let's get this. This is how they'll ask in the exam. The moment you see the 13 differentials, normally you will be gone only there only. You'll blast. You're like, what the hell? 13 differentials kya hota hai? Think. I'll give you a minute. So it's just based on what I wrote you right now. Let's see whether you'll be able to figure it out. Chalo, I'll help you with one. Then you try the other one. So what did we just now say? Every time you differentiate a vector, it rotates by 90 degrees. So let's say if this was your r bar, so this would be dr by dt. I will write simply as r1, okay? Yeah, lazy, so I'll put r1. If you differentiate 2 times, d square by r dt square, again rotate. So let's just call it as r to r1. I'll call it r2. If you differentiate again, you'll get r3. If you differentiate again, you'll get r4. Make sense? So every time differentiate, get a vector. Now, if you look at all those vectors, what is the resultant? 0, right? They'll cancel out now. 1 and 3 will cancel, 2 and 4 will cancel. So a set of 4 vectors will cancel out. Then again, if you differentiate, this is r5, this is r6, this is r7, and r8. Again, they will cancel. r9, r10, r11, r12. Again, they will cancel. You're only left with r13. So a set of 4 vectors will always cancel out. So the question what I gave indirectly, the answer becomes mod of the vector r bar only, which is, what is the answer then? 1, right? Clear? 1 to 12 all will cancel. We are left with only one vector whose magnitude is 1. I hope you're getting it. So this final answer would be mod of uh, r13 or d cube 13 by dt. This is basically 1. It's only single vector. Sure, everyone? Now using this same logic. So for this, you should know the previous concept. What if this guy is 14 and 14? What if this guy is 15? So what if I add 14 differentials? What if I add 15 differentials? Then what will be the answer? Try. If you have multiples of 4, it will be 0, right? That is understood. Get them. So these are the 4 possible answers you can get actually. And the idea is still the same. Whenever you add, the set of 4 vectors always cancel. 1 to 4 will always cancel. So what will be the answer for 14 differentials and 15 differentials and 16 differentials? This is how an advanced paragraph question would look like. They would explain you a small concept. You know what they'll explain you? They will explain you the story. They won't explain all this geometrical interpretation. They'll simply say, whenever a vector is differentiated, a constant vector, the parallel component won't change, only the perpendicular component will be there. Bas, itna explanation deke, they will leave you. And they'll directly ask you this 13 differentials. So they'll expect you to figure out that the dot product is 0. They'll expect you to prove this on your own. And they'll expect you to figure out that whenever you rotate, it rotates by 90 degrees. And then they'll expect you to solve this. Right now, it might feel very difficult for you, but when you're in 12th, you would have managed it actually. But even for your seniors, it is still a difficult question. Don't think like, "Arey, sorry, aisa kaisa kar payenge?" You'll be able to do. Right now, you are a little weak. But after 1 year, 2 years, you won't be this weak. You'll be very strong. Sometimes, if you see right now, right, your seniors have exam on 26th, 2 weeks more. You should see them actually. They do questions faster than me now. Happens a lot. And that is the whole purpose of a teacher actually. You guys should become better than me, at least on the day of the exam, isn't it? I was better than my teacher on the day of the exam. I can say confidently. That is what I am looking for. I'm training you so that you don't need me in the exam. So you have to become better than me. Right, Om? Arush, you're right. Because you have seniors right now, right? If you see them literally every day, they're solving almost 60, 60, 60, 180 to 200 questions per day. And they're doing this from last 3 months, like mad. So, and they have nothing else in life right now, isn't it? They only think of one thing. 2 week mein advance, 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 advance. That is what they're thinking of, 3 things. So when you have people like that, then you'll become super focused. Then you'll become better. Once the exam gets over, again they'll plummet. Let's see the first one. What to do? So in this guy, this would be 13. R13, and this guy would be R14. So basically the two vectors are perpendicular, right? So what is the magnitude? Root 2, na? It's not 1 plus 1. Be careful. It is like one I cap and one j cap. I hope you're getting that point. So it's two vectors ka resultant. So that is 1 and 1. The resultant is root 2. It is not 1 plus 1. It is 1 I cap and minus 1 j cap. This guy is 13, 14, and 15. So basically this is just one vector like this. So answer is 1. This guy is 0. They'll cancel out. Sure. They can put this in a more than one choice question. They'll ask you like this. They will say this is dn power n. And they will say if n is equal to 14, answer is this. N is equal to 15, answer is this. N is equal to 16, answer is this. So I can frame question like that. There. So these are the three possible answers actually. You can get a 0, you can get a 1, or you can get a root 2. Root 2 is interesting. It's not 2. Be careful with that. Vectors are perpendicular. Any doubts on this page? Please ask me. Yeah, next one. So that is one type of question there. 1 per second, 0 for last year. Now the another type is rate of change. Sometimes, right, they will frame the question like this. A cube of side A is changing at a rate of 1 centimeter per second. So indirectly he gave you dA by dt is 1 centimeter per second. Basically every second the cube ka sides are increasing by 1 centimeter. So they will say like this, find rate of change of surface area and volume of the cube when A is equal to 10 centimeter. Let me show you one model. So this is the word, rate of change. Whenever you hear the word, it means it is with respect to time. Anything that changes with time is called rate of change. Fine. So let me show you how it looks. So what he is indirectly saying is we have a cube here whose side is A. Now initially what is the side? I don't know. But every second it is increasing by 1 centimeter, 1 centimeter, 1 centimeter. So what will happen? The cube will keep becoming bigger and bigger. After some time, the cube will be this big. So the area is increasing, the volume is increasing. So the question is at what rate is the area increasing? At what rate is the volume increasing? Question is making sense? Try for 2 minutes. You think about this, how to do. Then I'll show you how to do one model. Okay. Okay. Let's see. Let me show you one. So the surface area is what? Surface area is 6 times a square. Let's just call it as S. So what you're asking me is basically ds by dt. That is the rate of change of surface area. That's it. That is the meaning of rate of change. He's simply asking you differentiation. So that would be d by dt 6a square. 6 comes out. Now be careful here. Here you are differentiating with time, but here it is a. So for time, t will think that a is some function. You're getting it? So we actually have to use a chain rule here. So d by dt, this is a to the power of 2. So this is some function actually. You're not differentiating with time, isn't it? This thing looks like t square, but it is not t inside. So it is 6 into 2 into that some function, and then differentiate that function, which is dA by dt. I hope this part is clear. This is the most confusing part. You're not differentiating. There's a difference between differentiating dt square by dt and differentiating dA square by dt. This case, it is 2t and dt by dt. Actually, even here we do that, but that becomes 1. So we always ignored that. I hope you're getting the difference. It is 6a square. A square is some function to the power of 2. So this is 12a ta by dt. So a ka value is given 10. dA by dt value is given 1. So that's 120 centimeter square per second. So every second your area is increasing at a rate of 120 centimeter square. Clear? Arush, did you take care of the dA by dt or did you forget that? Luckily, यहाँ पे क्या होता है ना? I'll do one thing. Wait, if I make it 2, now you'll get an error. Because it was 1, if you had forgotten also, you would have got the answer. So let's say it is 2. That's actually 240 centimeters per second. I changed a dA by dt. Because I gave it as 1, even if you had forgotten that, you would have got the same answer. But that would be a mistake. Can you do for volume now? Try, I'll give you a minute. So the main catch in this question is that when you're differentiating a square with time, you're not differentiating the time. It is a square ka differential. So it's I have to use a chain rule there. For volume, let's say. So for volume, the story is the same. Volume will be a cube. So dV by dt, now remember it is not time, it is a to the power of 3. So something to the power of 3. So 3 into a square, then differentiate whatever is inside. Just be careful with that part. This is the only thing that I am little concerned. Most people forget the dA by dt. If v had been t cube na, then I would have written 3 into t square. Actually, even there I will do this dt by dt, but that was always 1, so we never bothered to write it. I hope you're getting it. And then you're done. So a ka value is given as 10. dA by dt is 2. So that is 600 centimeter cube per second. So if the cube actually increases the side by 1, the volume is increasing at a rate of 600. I hope you're getting the meaning of this thing. Clear? Let's see one more. No, this time it is reverse. So rate of change of surface area of a sphere is 10 centimeters square per second. When radius is 2 centimeters. Find rate of change of volume when radius is 2 centimeters. Now it is reversed. I'm giving you change in surface area and I'm asking to find the rate of change of volume. Similar question, only the shape has changed. Give it a try. Ten centimeter cube per second. Okay, we have two answers. Both are saying 10, Devansh and Arush. Others, try, I'll give you a minute. Let's see. So what I gave you is not rate of radius, but rate of surface area. So surface area of a sphere is 4 pi r square. So ds by dt is 4 pi dr square by dt, which is 4 pi. R square differential is 2r, then differentiate whatever is inside. So that would be 8 pi r dr by dt. And ds by dt is given as 10. This is 8 pi, radius is 2, and this is dr by dt. So indirectly from here, I'm trying to calculate dr by dt. So this is the rate of change of radius. I didn't ask you this, but yeah. Now when you take for the volume, it is 4 by 3 pi r cube. So if I differentiate this, 4 by 3 pi r cube का differential is 3r square dr by dt. So this is 4 pi r square and dr by dt is 5 by 8 pi. That would be r square is 2, so that is 2 square into 5 by 2. Yeah, this is 10 centimeter cube per second. Please check. So from surface area, find dr by dt. From there, you go back to volume again. So we go a little round off. Clear with this? Great. Next one. Try this as a homework. I want you to give it a try. Can discuss this. Let's say we have a cone. There is a hole here at the bottom. So there is some liquid inside here. So liquid leaks at a rate of 10 centimeter cube per second. This is your slanting length. This is your height. Find rate of change of height when L is 3 centimeters. And this cone ka data, right? This was I'll do one thing. Let's keep it simple. Let's say this angle is 60 degrees. Half angle is 60 degrees. Question is clear? So we have a cone here filled with liquid. So an inverted cone. And the liquid leaks at a constant rate of 10 centimeter cube per second. So L is the slanting length and H is the height. So find the rate of change of height when the length is 3 centimeters. Clear with this? So that is one. So do give it a try with this. This is one type. Let's see another type of question. But I hope the question is understood. Applications will be like this. So let's say there is a floor here. There is a bulb here at the top. This height is 6 meters. And we have a person here whose height is 2 meters. So what happens from here? So the light will go like this, and that is the last light ray. This black thing would be the shadow. And this point is P. This is the shadow of the head. And this man is walking with a speed of 2 meters per second. So this is a bulb at a height of 6 meters. Question is clear what is happening? You must have seen this thing, right? When you're walking on a road, there's a light behind, you can see your shadow on the road. Find the speed of point P. Now see, P is not constant, even P will go forward. Find the rate of change of length of shadow. Means at what rate is the shadow increasing in length? Let's get this. How do we approach this? This is what I was saying. The differentiation is actually easy. The headache is converting a problem into an equation to differentiate. That is always the toughest part. And that will take time. That you can't just learn it in a day or two. As time passes, as we keep doing more varieties, as we're doing different chapters, you will figure out. Matlab, it might take months. That is okay. But somewhere we have to start. This issue, right? Even your seniors have it till today. It's not that easy. You need a lot of practice, but you'll get the hang of it. Don't think like, "Arey yaar, sir, aisa kuch problem there, I'm not getting it." Think the other way around. Good, na? You're not getting means you're getting to learn something new. I'll tell you one simple thing. See, if I teach you 10 questions, and if you got all the 10 questions, what does it mean? I'm not teaching you anything new. Isn't it? So if I teach you 10, and if you're getting only 1 or 2, or if you're not getting anything, that is fine. Na? You're trying to learn. So don't try to, compete yourself with me here. In the class, you're just trying to learn. You want to compete? Every week I have an exam on Thursday. Compete in that. Try to score 90%, 80% in that. I hope this week a test everyone has given. You have a deadline today night, 11 o'clock. So it's totally fine. Just try to see the problem, understand, and try to solve. Don't worry about, "Hey, I'm not getting answers." You're here to learn. So exam is to score, class is to learn. So don't mix up both of them. The biggest problem is that. How do we approach this? Yeah, after giving explanation, if you're still not understanding now, that's an issue. But I hope all are understanding after I'm explaining how things are done. Then it is fine. That means you're learning. How do we approach this? This problem I'm teaching from long time. And it was not a big problem actually, I think, but last year it came in the advanced paper. Numbers are different, but it is the same question. Even I was surprised. But it is a good one. See how to approach this. Question is actually easy. Figuring out the data was the thing. So this is what we do. Let this length be x. Let this length be y. So y is the length of the shadow. This is point P. Now tell me one thing. What are the coordinates of the man? Coordinates of the man is x comma 0. What is the coordinates of P? X plus y comma 0. Agreed? Now from this triangle, we can see if this is angle theta, tan theta opposite side 6 by x plus y is also equal to 2 by y. Similar triangles. 2 by y should be equal to 6 by x plus y. So what is theta? I don't know. So that would be 2s are 3. Y is equal to x plus y. So we have x is 2y or y is equal to x by 2. What is the meaning of this? Every time the man walks a distance of 2 meters, the shadow will increase by 1 meter, isn't it? Y is always x by 2. So you want velocity of point P, which is first of all, so what is velocity of the man? Tell me one thing, when the man is walking, what will change? If the man is walking at a rate of 2 meters per second, that means x is changing at what rate? 2 meters, isn't it? Velocity of man is nothing but dx by dt, which is nothing but 2 meters per second. Do you guys agree with this? Every time the man walks 1 second, the x will increase by x plus 2, x plus 4, x plus 6, x plus 8. Means the x is changing at a rate of what? 2 meters every second, isn't it? So what is velocity of point P? Vp is nothing but dy dt of x plus y. But I know y is x plus 2. So that is dt by dt of 3x by 2. So that is 3 by 2 dx by dt. But dx by dt is 2. That is 3 meters per second. That means whenever the man is walking with 2 meters per second, the head is going forward by 3 meters per second. And what is rate of change of length of the shadow? Rate of change of length of the shadow is nothing but dy by dt. Y is the length of the shadow, but y is x by 2. So half dx by dt. That is nothing but 1 meter per second. So every second your shadow is increasing by 1 meter per second. So if you think about it, it kind of makes sense because see, every time the man walks forward, it will increase by 2 meters and the shadow is increasing at a rate of 1 meter. So your head is going at a rate of 3 meters per second. You're making sense? The shadow is going forward because of two reasons. One, because you're walking forward, the shadow also will go forward. Second, the shadow is expanding, so the P will also go forward. So the man is walking 2 meters per second, shadow is increasing 1 meter per second. That's where the head is going 3 meters per second. Tell me one thing, is this differentiation actually difficult? कुछ है ही नहीं ना differentiation. But did you see what happened there? Getting that format, right? dx by dt, dy by dt, that was the headache in this problem. Have a look at this. Sure. Any doubts on this? So a similar one, you guys try it as a homework. So we have a light bulb here. Let's say this height is 10 meters. So here we have some bird here flying with a speed of 3 meters per second. So then what will happen? This will be the shadow of the bird, isn't it? And let's say this height is 3 meters. Able to visualize the situation? There is a bulb at the top, or you can say there's a sun there, whatever, doesn't matter. And there is the bird flying at a height of 3 meters, and it is coming towards the electric pole. Find the speed of the shadow of the bird. Question is making sense? Similar to the previous one, but in this case, there's a bird flying towards an electric pole and there's a bulb at the top. So there'll be a shadow of the bird on the floor. So find the speed of the shadow of the bird. Clear? So try this one, 19th and the 17th. So on Wednesday, when we catch up, the first thing in the class, we will discuss these two, and then we'll start off with a next topic called maximum minima. That is even more interesting, have more applications on this. So mostly next 1.5 class, we should wrap up differentiation, and then next week we'll start off with integration. So mostly we will finish off this chapter in another 3-4 classes max, and then we'll go to kinematics then. But I hope you're seeing differentiation, how we actually use it. That's what I said, that big differentiation we saw, that is really not that important. The headache is this problem. Imagine this was an advanced problem last year. It was not tough, but framing a question, right, is a headache there. How do you visualize what is changing when something is moving? Clear with this? Okay, so with that, we'll wrap up for the day. So we'll catch up on Wednesday at 8:45 as usual timing, and then we will continue from here. So, and there is an exam today online till 11 o'clock, so make sure to give. Okay, so and we'll start maximum in the next class. So do make sure to go through the entire notes once. So any doubts, anything, you can stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you guys in the next class.